Hi girls, welcome to my first chemistry video on percentage composition. So all we're going to be doing is we're going to be going through page 37 on your notes. So that's the one with a picture that looks a little bit something like this. All right, so can you find that page? If you need to pause, that's fine, but that's the beauty of video is I get to keep talking. All right, so let's start by looking at the top there. So percentage composition is figuring out what the percentage of each element within a compound is. Okay, so when we have a look at your gaps there, it says the theoretical blank by blank of a compound gives us. Okay, so what we're talking about here is the theoretical percentage composition by mass. Okay, now the good thing about this is that I can show you here what we're talking about. So this is what the notes say. Okay, so the theoretical percentage composition by mass of a compound gives us the percentage of its mass contributed by each element present. For example, and this is the example we're about to work through, the compound potassium dichromate. So the compound potassium dichromate is K2Cr2O7, and we can calculate the percentage of each element, and this is hopefully what we're going to end up with, using their molar masses, so using your periodic table. So if you haven't got your periodic table, pause, go get your periodic table. The other thing you're going to need for this video is a calculator. So whenever we do quantitative chemistry, we're always going to need a calculator and we're always going to need our periodic table. Okay, so let's go back to here and have a look. So here is our formula. Our formula for percentage composition is the mass of an element in a 1 mole compound over the mass of 1 mole of the whole compound. Now we're going to break that down. You'll see that this one's actually probably one of the easier calculations that we're going to do. Now also because it's a percentage, we're going to times it by 100. So we're going to look at the percentage of each element in K2Cr07. So we're going to go one element at a time. So what I'm going to do is I'm just going to switch us over to a blank screen and we should be able to talk through this here. So the first thing that we do is we go the percentage of potassium. Okay, so we're going to need our percentage of potassium. So to do that, we need the mass of potassium within the compound. So how many potassiums do we have? We have 2 of them. We're going to times it by its mass from the periodic table, which is 39.1. Okay, and we're going to do that over the mass of the entire compound. So the entire compound, I'm just going to write it over here for our to remember it, is K2Cr2O7. Oh, sorry, that's not going to fit. Let's try again. So my entire compound is K2Cr2O7. Good. So what are we going to do for that then? It's going to be 2 times 39.1, okay, because that's 2 times potassium, plus 2 times chromium, which is going to be 2 times 52.0, plus 7 times oxygen, plus 7 times 16.0. Okay, and then we're going to do all of that times 100. All right, when we multiply that out, and you can pause and do this on your calculator, we should end up with 78.2 divided by 294.2 times 100. One more step gives us 26.5%. Yeah, and that's the percentage of potassium in K2Cr2O7. All right, now how many sig figs do we need? I can see that there are 1, 2, 3 sig figs, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, everything seems to have 3 sig figs. So my answer should be in 3 sig figs. Okay. So just working through that, you can see that here's the same thing. Add that in, end up with 26.6 this time. I'm not sure which one I rounded correctly. You'll be able to tell me that, I'm sure. So now we're going to do it again. but this time we're going to do it for oxygen. So what we do is we come back to our board and we say, now I'm going to look for the percentage of oxygen in K2Cr2O7. Okay, so what do we need? We need the mass of oxygen at the top. So that's 7 times 16, because there are 7 of them, over that entire mass before. Now, you can just use it. I'm just going to use it from before. So it was 294.2. Okay, and we're going to times that by 100. I'm going to expand my top. 294.2 times 100. And then we end up with 38.1% oxygen. Okay, not too bad. Let's just check ourselves. Yeah. 38, this one was rounded down. Okay, last one, let's just look at the percentage of chromium. So you should probably pause here, give it a go yourself, and then see if you're correct. So the percentage of chromium, how many chromiums do we have in K2Cr2O7? You can see that we have 2 of them. So we go 2 times, reading off the periodic table, 52 over 294.2, because that hasn't changed, times 100 equals 104 over 294.2 times 100. And that equals 35.4%. Okay, nice and easy. Let's just check. 2 times 52, 104 over that, 35.4%. Now that is it for a work through on percentage composition. There are some questions in question time. Let's just have a look and see which ones are the best to do here. I think you can go and do questions 15, 16, and I want you to give 17 a go. 17 is a bit trickier. That's mixed with a mole question. Okay, but I want you to give them both a go.